this is Calculus 12, Chapter 3.8. We're going to be looking at derivatives of inverse functions. Okay, on page 158 is your theorem. Theorem 3, derivative of inverse functions. If f is a differentiable function at every point of an interval I, and df dx is never 0 on I, then f has an inverse, and the inverse is differentiable at every point on the interval f of I. So this means domain of the inverse of f is f of I. Okay, because f of I will be the range of the function. And remember, we swap domain and range for the inverse function. So the question is, why do we have this restriction of df dx is never 0? I'll give you a second to think about that. And because if we're dividing by 0, this is a vertical tangent for the inverse, okay? If it's 0 for f, then it becomes a vertical tangent for the inverse. Okay, big picture. If we can differentiate, it stands that we can take the reciprocal of the derivative. Okay, and what inverse functions are we interested in? Well, we're interested in the inverse trig functions. So we'll start off the proof. So we want to take the inverse of both sides. And now we can implicitly differentiate. So we couldn't do this before we learned implicit differentiation. So we have y prime, cos y. Remember, if we're doing y, we have to use the chain rule and get y prime. And the derivative of x is just 1. So y prime equals 1 over cos x. This is good, but we need to solve in terms of x. Our derivative rule is not too useful if we have it in terms of y. So we have to take use of a basic identity. Sine squared y plus cos squared y equals 1. It's an identity. Okay, and we want cos squared y equals 1 minus sine squared y, and then cos y equals plus or minus the square root of 1 minus sine squared y. This is our trick. And we have to reason out, since domain of sine theta is negative pi over 2, that means the domain is here. And we have all students take calculus, so cosine is positive in these two quadrants. That means we can eliminate the negative sign. So cos y equals square root 1 minus sine squared y. Now, what is sine squared y? Well, sine y is x. So this must be 1 minus x squared. So y prime equals 1 over square root 1 minus x squared. We're subbing in x equals sine y. Therefore, d dx of inverse sine x equals 1 over square root 1 minus x squared. Okay, so here's some inverse identities, but we're more interested in the derivatives. Okay, so here's your other derivatives. Inverse cos x. It's the same as inverse sine x, but we have a negative sign. Inverse tan x, we have 1 over 1 plus x squared. And we use these ones less, but you should still learn them. The order changes, it's x squared minus 1. Inverse cosecant becomes negative, and we add an x in front as well. Inverse secant, it's identical to inverse cosecant, but it's positive. And inverse cotangent, it's the same as inverse tangent, but we have a negative sign. Okay, let's look at some examples. We have inverse sine of x cubed. So substitution, let u equals x cubed. The derivative of u with respect to x is 3x squared. F prime of u, take the derivative with respect to x, inverse sine, u, and then we need to multiply this by du dx because it's a chain rule. We have a composition. So we use the rule for inverse sine, which we have up here, 1 over square root 1 minus. So it's going to be u squared. And u equals x cubed. We have x to the power of 6. And now we need to multiply it by du dx. That's 3x squared. So we can simply write it as 3x squared over square root 1 minus x to the power of 6. This does not simplify. Okay, and just a reminder, this was 1 minus u squared. Okay, we need to evaluate this at point 2. So f prime at point 2 equals 3.2 squared, square root of 1 minus 0.2 to the power of 6. This equals 0.04, so we have 0.12 over square root 1 minus 2 to the power of 6 is 64. We need 6 decimal places, 1, 2, 3, 4, and then 64. So that's our exact value. We can get an approximate value of 0.12. This is very small, it's very close to 1. Next example. Okay, chain rule here, no chain rule here. And hopefully you can see the chain rule and just use it right away. So we need cotangent and tangent. And you can just refer to your sheet and I won't have to scroll. So we have minus 1 over 1 plus x squared. This is your x. So we have 1 over x squared. We need to multiply by the derivative of this. This is x to the power of negative 1. So we have negative x to the power of negative 2 minus, and then we have 1 over 1 plus x squared. Okay, no chain rule here. That's just x, so we can just plug it in. Okay, we need to simplify this. So it'll be a little bit of work, negative 1. So we need to multiply by a common denominator. That would be x squared. So we have x squared plus 1 over x squared times negative 1 over x squared minus 1 over 1 plus x squared. Okay, make sure that this has a shorter bar. If this is a fraction in the denominator, the numerator is just a constant. Since we have a fraction in the denominator, we're going to multiply by the reciprocal. These two negatives cancel out, so I'm just going to have x squared over 1 plus x squared, and we have 1 over x squared minus 1 over 1 plus x squared. These two cancel out. We have 1 over 1 plus x squared minus 1 over 1 plus x squared. And the answer is 0. That's a lot of work to find out that the answer is 0. Next question. We see that we have a composition, so it's a chain rule. We also have a quotient, so we need a quotient rule and a chain rule. And that's what the hint says. So f prime of t. Okay, the derivative of the numerator is 0. So we don't have to multiply by the denominator. Derivative of the denominator, that's minus 1 over square root 1 minus x squared. So this is your x. So we need to do 3t squared squared. And we need to multiply by the derivative of this. That's just 6t. And now we need to square the denominator. So this is cos inverse 3t squared all squared. Okay, now we can simplify this. Oh, I forgot to mention that we need to multiply by the numerator, but the numerator is just 1, so we don't have to do anything there. Simplify, we have 6t over square root 1 minus 9t to the power of 4 multiplied by inverse cos 3t squared all squared. Okay, you also have the option to use the power chain rule. Okay, all we have to do is substitute now. F prime of 0.4 equals 6 times 0.4 over square root 1 minus 9 times 0.4 to the power of 4 and we have inverse cos of, we have 0.4 squared, that's 0.16 times 3 is 0.48 and squared. We can simplify this to 0.24 over square root 0.7696, and this doesn't change, it doesn't simplify any. Okay, and if you want to punch it in on your calculator, you're going to get an approximate value 2.39. Check the question on the test to see if it's asking for an exact answer or an approximation. And if we did the power rule, we have f of t is inverse cos 3t squared to the power of negative 1. So we have negative. We have the same thing, and then we decrease the power by 1. Now we need to do the derivative of inverse cos 3t squared. So we get 1 over, and we have to use the inverse cosine rule. And that would actually give us a negative here. And then derivative 3t squared. And we get the same as before. These two negatives cancel out and you get a positive, which is what we have here. And here's another property that might help you. The derivative of an inverse function at f of a is d dx of the inverse function of f of a. This is a y value equals 1 over f prime of a. That's your x value. But that does not equal the derivative of the inverse of f at a. Okay, so what you want to notice here, we can't take the derivative of the inverse at a. The derivative of the inverse needs to be done at f of a. That equals the reciprocal of the derivative of f at a. And that completes this lesson.